The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here with Mr. Dane DuPont from the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, December 7th. Please ignore my bad label of December 8th on our tags here below and elsewhere. Thursday, December 7th, 2023. And Kilauea has been quaking, Dane. How are you today?
Yeah, managed to actually feel those ones this time. Usually I just blame the dog and move on, but this time I felt both of those two things. So was interesting. You know, they had different signatures. You know, they felt very different for me. I heard some other people describe them as similar, right? But the first one felt, I was actually surprised when it was a 4.4, but it was so much deeper, right? The depth of it made it so different on the feeling, but yeah, initially I was like, oh, that can't be that big, you know, when it hit the 4.4.
Yeah.
So we'll talk about that more.
It all depends where you are, and I'm sure everyone watching will have felt it slightly differently depending on where you are on the island. I'm living in Volcano, so that second one felt pretty close to as strong as the first one. It happened to be right in a barrel, facing the barrel of it.
Right.
So that would be why. Anyways, we'll talk about the earthquakes here. Kilauea's had all three kinds of earthquakes this week that it normally has. One being those deep settling earthquakes, flex earthquakes. The other being the volcanic tectonic earthquakes, the south flank moving That was a 5.1 we had on Monday, and then yesterday the deep flexure. What's what I'm missing? No, the last one is the volcanic swarms, which is all the little bumps you see here in the middle, all around the summit, which we've been having happening for the last 2 months now. So we'll go over all of that in some detail here. Dana will be taking questions and leading a discussion in the chat. And we'll be talking lots of earthquakes today. So anything else, Dane, before we jump in it?
No, I think that's it for me. We'd like to thank Carrie and Dano. They will be stepping away for a couple weeks after tonight. So we appreciate them being back, the two of them together, to give us some ASO interpretation of this presentation. And with that, I think you can take it away, Phil.
Mahalo, you guys. All right, let's switch our screen up here. Put our tags up. And let's start. Here's this week's Hawaiian Volcano summary. As you can see here, this map of earthquakes on Kilauea for the last week. There have been 2 big events. This big orange one was a magnitude 5.1 South Flank earthquake that occurred on Monday. This big blue one was a deep settling flexure earthquake that occurred on Wednesday, yesterday. And in between, we have all the small volcanic earthquakes that continue to flare up every few days, depending on whether magma is filling and pushing or whether it's able to relax a little bit there. So that's the story on Kilauea. It's much the same as in recent weeks, apart from the big earthquakes. If we look at the earthquake rates on Kilauea for the last month, earthquakes per day, we see that today we are actually experiencing an uptick of earthquakes. And we had the last couple of events last weekend on Friday and Saturday there. So not quite as high as events earlier in this month. And remember, this has been going on since the beginning of October. So that initial pulse back then was really the biggest flurry of earthquake counts we've had so far. So it's pretty typical, right, with this cycle of it ramping up, then down, and up, and down, and up, and down, and maybe a little and up and down. That's the pattern of it pulsing the magma supply through this now open system. And the reason we can believe that it's doing that is we can look at the ground tilt at the Sand Hill station, where the blue line points towards Halemaʻumaʻu and the green line points to the area south and west. That's been the intrusion area. And they are presently both inflating at the moment. So magma is still coming into the volcano and swelling both areas. And at the same time, we can still look at the outlet station. You can see the ground is still rising quite rapidly. And much further to the southwest at the Hilina Pali station, the ground is still trucking along to the south fairly rapidly as well. So the effects are still fairly widespread there. This station here is about 7 miles from the summit, and there are earthquakes even beyond this. So it's the same story as we've seen for the last 2 months, with a few extra earthquakes. On Mauna Loa, the story has been that earthquake rates have gone down. Here are the earthquake counts per day. This is a range of 0 to 6, so very few. You can see that it looks spiky because we're so zoomed into the graph, really. If we look at the last year, we see the spike of deep and shallow earthquakes we had last month. And since then, it's really dropped off pretty dramatically. So that increased activity is pretty small compared to what we saw building up to the eruption last year. And for the 4 years prior to that, where we still had a longer term buildup. So Mauna Loa is still feeling fairly quietly, with the first signal of this shallow pressure occurring, and much more would be needed until it's ready to erupt. So that's the Hawaiian Volcano summary for the week. And with that, we'll turn to Kilauea first here and look at, this is the live camera looking in there. we don't have a whole lot of visual reports to give you guys today. We'll focus more on the earthquakes. But to start off, here's a live look in with all this sulfur mineralization occurring where the gas is leaking through this crust. Remember, underneath all this gray hardened lava, there's still liquid magma underneath there. And it's degassing, and that gas leaks out through the cracks. And when it comes into the air, it's depositing those minerals around the cracks. So there's Kilauea today. Let's move on and get our volcanic hazard out of the way by looking at the VOG measurement and projection project at University of Hawaii, Manoa. This is our VOG forecast. And it looks like this. We have very little gas coming out of the volcano in volcanic terms, about 100 tons per day of SO2. But that's still quite a lot for people living nearby, and people in this volcano area especially, and some areas to the southwest may experience effects in the next few days here. So that's mostly because of the winds, whereas the emission rates are fairly low. We expect emission rates to get much, much worse by a factor of, let's say, 1,000-ish, if an eruption actually does occur. During that first pulse of breaking the ground, a big burp of gas comes out. So that's what you need to prepare for during these times when it's fairly mellow for the volcano. So that's our volcanic hazard as far as the gas. But today we're going to do a little extra to shift over and bridge the gap here into the earthquakes. Right? So we're going to go into our recent earthquakes. I'll put that on the screen here, but we're still talking hazards. Because our mission at HVERI is to improve preparedness and response through education, right, of volcanoes and earthquakes and all the associated things. So pretty basically here, top level overview, what can you do to prepare for an earthquake? In case you were wondering when the ground was shaking those many seconds on Monday or Wednesday, wherever you may have been. Step one, secure your space by identifying the hazards and securing movable items. I'm going to make sure stuff's not going to fall on you, basically, right? Step two, plan to be safe by creating a disaster plan and deciding how you will communicate. So that's stuff like look around you and where is the desk you can hide under? Where is the door frame? Where is some big furniture that might be, if it's steady and attached to the wall, for example, that you might take shelter next to? Right? How are you going to evacuate? How are you going to regroup afterwards? All the planning parts of it. Step three, organize disaster supplies in convenient locations. We'll look at this here more in a minute. And step four, minimize financial hardship by having your documents, by strengthening the weak parts of your property and making sure you have the right insurances. This is all recommended by the Earthquake Country Alliance, which is a partner with the USGS. And they actually have a webpage that is earthquakecountry.org. And this is in a little bit more detail what that might look like, securing your space, right? So making sure you have all your heavy stuff attached to the walls. Don't have heavy stuff on the highest shelves, put it on the lower shelves where you can. That kind of thing, right? Water heaters are a big one. Televisions on a wall, big heavy things, those kind of things, make extra sure. Why is this important? Several people died and thousands were injured in 1994 Northridge earthquake in California because of unsecured items such as toppling bookcases. They did a study at UCLA. 55% of injuries were caused by falling furniture or objects. Only 1% were caused by building damage. All right, so that's your lesson there. What's most likely to get you is stuff falling on you from your own shelves, your own furniture that's not attached to the wall, that kind of thing. So there's a lot of stuff you could go through there. Right? There's this website if you want to go through in more detail. I won't go through every little thing, but I mentioned some of this already. The no-cost things, moving the heavy stuff down, moving heavy things that can fall on you away from where you spend a lot of time, moving heavy or unstable objects away from your escape routes and doors, so you're not blocking your pathways out. Low cost, secure your water heater and furniture, mirrors and pictures, computers and TVs. Small objects, it says you could use museum putty or wax, right, to just attach things so they're not rocking during a big shaking. Latches on cabinets. If you're somewhere really at risk, you might invest more time and money with flexible gas connections, secure overhead lights, and all the freestanding stuff, right? And besides that, there's all kinds of building stuff that you can look at as well. So that's step one of it. And step two, to plan by having the communication and the evacuation plans there, right? That includes knowing that during the earthquake, what do you do? Drop, cover, and hold on. Right? Identifies the safe spots, such as under sturdy desks and tables, and figure out where you are. How close are you to the exit? Are you going to plan to go outside? Are you going to plan to stay inside? Where are you going to stay inside? That kind of thing. Just think through it. Right? That's the kind of thing that happens during the earthquake. You may not have much time unless you've thought about it already. Right after the earthquake, that's where they plan a little bit more than most people here. They suggest keep shoes and flashlights in a closed under the bed bag, tied to each bed. That's if you're in California and you're really worried about it, that's what you do. You get under your bed, you know where all your stuff is right away, even if it's dark and you've had damage to your structure. Teach everyone to use emergency whistles and knock 3 times repeatedly if trapped, because rescuers listen for sounds. Know the location of utility shutoffs. Install and test and change batteries on your smoke alarms. CPR training. CERT teams, those kind of community groups that help everyone prepare and respond. Meeting your neighbors, your neighborhood programs. For us here on Hawaii Island, we work with Vibrant Hawaii with the resilience hubs to take care of a lot of this stuff and package it all together so that if someone has impact, they can go and have a lot of the resources in one place already. And then what do you do after the earthquake? Where do you evacuate to? Where do you regroup? Do you have all the contact phone numbers? Those kind of things. Where do you go if you can't live in your home anymore? That's what they're noting. And one thing that they especially note here that I thought I would read, since I am a parent, because adults often respond to the emergency. The kids are often secondary, and they are just as alarmed because they also are feeling out of control there. Right, so that's just one thing to think about there on that planning stage.
Also, a little note about animals, because as we've seen before, when something happens, the animals get panicked too, and they're often a second or even third consideration. So they can run away and really upend a plan, right? Like you have this whole plan, you're going to put them in the container, you're going to cart them away, and now they're in the bush running, right? And good luck. So that's always something to consider.
Yeah, exactly. Think it through. Well, not that you can plan when earthquake's going to happen, but you can have thought through some different situations. So for their organizing supplies, step 3 here, they say that you should have several caches of supplies around your house. They say under the bed bags, you can have shoes, flashlight, and other items if something happens while you're sleeping. Go bags or car kits for about 3 days when evacuation is needed. So if you're living out of your car, for example. And home or work supplies for sheltering in place up to 2 weeks, or for larger groups there. So those are some different ways that they can prepare. And I won't read through all of this, but if you really like to, you can pause the video here and read all these items. All kinds of things suggested by this organization for under the bed bags, essential and optional, go bags and car kits there. All kinds of radios, dust masks, things people don't think about. It might be dusty and dark. So things like eye drops and cleaning solution for contacts. And household and workspace supplies, there is that list up there. Right? And part of this includes having enough water, right, our most important resource, minimum 1 gallon each day per person. Different kinds of foods, and those are things you can rotate out on a yearly basis: food, water, medications, and batteries. So there's a lot of stuff applies to more than just earthquakes, but if you were prepared for an earthquake to hit without any warning, then a lot of other things would be fairly easy as well, right? These bags that you have can be multiple purpose.
I'd also just add, I don't see it on there, but 100-foot of paracord and duct tape are also just good essential items to have in a kit like that. They're lightweight and not a lot of space take up, and very useful.
Yeah. I haven't read through every little item here, but yeah. So let's just keep going to not get too bogged down here. And the last one, to minimize financial hardship, organizing important documents. Nowadays, if you can have things online in a cloud, that's really useful. That's not how it is with the older generation sometimes, and some of the property documents especially, right? Whether it's leases or deeds or those kind of things. A lot of times there's still paper copies that you want to make sure you have those safe. Common problems on houses: foundations, unbraced walls, soft first stories, a lot of open space on the lower floors, unreinforced masonry, houses that were built before building codes were put in place. There's a lot of that out here in Hawaii. So those are the structural things to consider as well, right? As you want to minimize your financial hardship. If there is an event, how can you prevent damage just from reinforcing the house? So earthquakecountry.org, and you can, or Google Earthquake Country Alliance, you can find these steps, right? There's actually 7 steps detailed here, right? Besides this, they go on to survive, drop, cover, and hold on, improve your safety, reconnect, and restore as well. So I won't go through all of that here today, but we wanted to just give a little insight, provoke a little bit of thought and on preparedness for earthquakes as well. We all often talk about volcanoes as like the most attractive, popular disaster because it's pretty and very striking, right? But lava flows get very few people, whereas earthquakes are guaranteed to affect just about everybody. So most of us are most likely to be impacted by an earthquake above everything else. And that's why it's so important to think about this and be prepared. So, all right, that was our volcanic hazard summary / recent earthquake bridge right there. And with that said, let's turn to the 3 types of earthquakes in Hawaii. This is a slide from the USGS that's showing the 3 kinds of earthquakes. What we call flex earthquakes, or I sometimes call them settling earthquakes, shown as flexural mantle earthquakes up here in the top left. Volcanic or magmatic earthquakes, that's like what we're seeing with the intrusion, where earthquakes are moving through a rock, causing lots of small breaks. There is actually a harmonic tremor as fluid moves through the cracks, and the locations of the earthquakes can move with time. That's what you get with these volcanic earthquakes, right? The flexural ones are usually very deep near the base, within this base of the island, right there. The third one is this tectonic. Here it's labeled edifice as well. That's stuff like the south flank moving, where you have magma filling within Kilauea. It pushes sideways, and that causes the side of the island to migrate and move, and that involves faults, and those faults generate earthquakes. Those are the 3 kinds. This is a great week to talk about it because we have great examples of all of them at the same time. There may not be a better week that I've seen before. So our first example, this magnitude 5.1 that occurred on Monday down here, the south part of the island. This is the map of felt reports So every little square is an area where people submitted reports of what the earthquake felt like to them. So you can see it was felt island-wide and as far as 2 responses on Maui. So this 5.1 was felt as far as Maui. On this map, there were over 1,100 responses that came in. That's a good number. So that was the first one. We'll just do a brief overview now here, and then we'll get into the details of all of them. USGS puts out an information statement on Monday about that 5.1. Here it is. A magnitude 5.1 occurred at a depth of 1 mile below sea level, 2 kilometers. Pretty shallow there. The size and location of this earthquake indicate it is related to shallow movement on the Pali system of Kilauea's south flank and is not directly related to volcanic activity. They do note that there was 1 magnitude 3 aftershock, and others could occur as well. So that was our tectonic flank earthquake. 2 days later, yesterday on Wednesday, we had our 4.4 at a depth of 23 kilometers down, a little bit more inland. Right? This is pretty close to the caldera area, right near Volcano Village. Felt reports also island-wide, not on Maui. And in this case, over 300 reports. So while it was felt island-wide, it was not felt by as many people, and it was not reported by as many people. Not quite as alarming. Right? So since I live right there, I felt that one pretty strong, just like that first one. Not quite as strong as the first one, but pretty intense too. And the USGS also issued an information statement for that one. A magnitude 4.4 earthquake, Wednesday, December 6th, near the town of Volcano, at a depth of 23 kilometers, 14 miles below sea level. The size and location of this earthquake indicate it is related to flexing of the oceanic crust buried deep below the island, and is not related to volcanic activity, nor is it an aftershock of the magnitude 5.1 earthquake. There have been no detectable changes at nearby Kilauea. Monitoring continues. So that was the flex earthquake. And the last set of earthquakes is what we've been talking about for 2 months now, here in the Southwest Rift, with this area of uplift mapped in satellites being all through here, causing earthquakes to occur along the Southwest Rift connector, and all the way down to the past the Kamakaya Hills. We're over here as well. So those are the 3 kinds. We can go into more details since that's what everyone is here asking about. Something went wrong with the earthquakes page. Let's try it again. There is an earthquakes page. So here are the earthquakes for Hawaii Island. All these ones you see surrounding the island, those are these flex earthquakes happening all the time, right? When they're offshore, they're easier to detect because there's not any volcano causing those kind of earthquakes out there. But these can occur under the island as well, and they mix in on this kind of map. So zooming into Kilauea, this is the location of the 5.1 right there, and its associated aftershocks. You can see right below those steep hillsides of the south flank. And this one up here was a 4.4 deep under Volcano Village. Volcano Village is right here. And that one, pretty close to the caldera. It looks close this way, but it's really so far down that it's as close, it's as close to here because it's so deep as it is to here, basically. It's more deep than it is near anything on the surface. So that's Kilauea's view of Kilauea's activity. And here are earthquakes for the last week in this area, which are now focusing closer to the caldera in an upper southwest rift connector and upper east rift connector too over here. Right, these are a little bit of a isolated cloud, but still ongoing pretty steadily for the last month or so. Right, so these earthquakes are colored by time, with red being the most recent. So ongoing earthquakes still there and there, even as we speak. And this is part of the elevated counts that we've seen all day here today. But as you know, I like to plot these by depth in the color as well. So here is a series of images I've pulled from the USGS site, colored by depth. The blue ones are the deeper ones, the red ones are the shallow. Here you see that overlap zone. But really, we have three areas of earthquakes. We have the southwest rift connector zone right here, that's near the summit. We have the further southwest rift off here separately. And then we have separately this east rift connector patch as well, right there. Those are the three main ones. And then you also have all the south flank events. That's this cluster down here, which includes our big one this past week. What we'll do is filter out the deep earthquakes and look at the shallow events near the surface as we dive into the volcanic earthquakes here. And making a cross-section that includes all three of those upper populations there. We can see that this is the earthquake counts. How many earthquakes over the last month? When a line is steep, they're happening really fast. When it's less steep, they're happening not as fast. So these are the pulses. There is one pulse, two pulses, three pulses, 4, 5, 6, 7. This is the 8th pulse, if you believe how I divided it up here. Right, and still ongoing strong. And looking at it, depth versus time, that same month, this is showing the range of depths those earthquakes occur at. So they're occurring as these vertical streaks here. Let me change my color so you can maybe see this better. Right there. So these vertical streaks. There's one, another one there, another one there, another one there, another one there. So these are those pulses coming through with gaps in between, like really cycling through. This is a really different pattern than what we saw for all eruption buildup before, right? This is really an extended filling the area around the summit, as we've been talking about for the last couple of months. So to look at it in cross-section, just to remind you, I'll pull this map back up. There's A and there's B. A is southwest, B is northeast. Southwest, northeast. And here's what this looks like in a cut through the ground in a cross-section. This is that furthest southwest cluster of earthquakes right here. And you see they span a good depth range of over a mile, right, bottom to top. But the upper events are a little deeper than you see them near the caldera. A couple exceptions here, right? Near the caldera, you see that zone is inclined to the east right there. And then separately, there is that east rift connector population to the right over here. There's three different clusters with a little gap in between, notably too. So we'll look a little more closely. Let's divide and let's exclude that east rift stuff and look just to the southwest. In that case, a little more clearly, you see the pulses. This is just the last week now. So 3 pulses over the last week. There's the 3 pulses, 1, 2, 3. Depth versus time. And in cross-section, zoomed into it, we're ignoring the stuff to the east now. Here is that southwest cluster of earthquakes, and the one just south of the caldera. So remember, the earthquakes are happening where the rock is breaking. Within the magma itself, in the middle of that blade, there is no earthquakes because it's just fluid. You can't crack a fluid. So it's where that fluid is pushing against rock and either forcing its way through to break it, or potentially pushing a rock and causing it to move along a fault. And that fault is causing the earthquakes by grinding the rocks in between the fault plane there. Rocks breaking once again as well. Right? But 2 different ways that rocks can break, either from magma pushing or from the faults grinding them down. And if you look at the pattern here, you might think there is a slight decrease in depth, right? Or increase in depth. It's getting deeper further southwest. So it could be that as the magma is entering this crack system, it's just moving potentially with the aid of gravity to some degree, even though this is all underground, right? To move to those lower parts further off the center of the volcano here. We'll see. We really like to see some INSAR that goes all the way down to the southwest area to get a better picture, but that is what it appears to be happening. INSAR being satellite data. So this is the best we can see without the satellites so far. If we look together, let's ignore this further southwest patch now. Let's look at this near summit area, both the southwest and the southeast. Once again, you see pretty clearly these pulses, right? So when we see this other plot where the pulses are not quite as clear, it's a little bit more muddled, right? Not quite as flat in between. It's because we're combining different areas, right? So what we're seeing here is if we look at where was I? This one right here, just in that upper area close to the summit, it's much more clearly start and stop and start and stop. And it's getting muddled up because during these stop areas, that's when that other area to the southwest is also still active. So that makes it still not stop all the way, right? So that's showing you the pulse moving through the system from the summit towards the distal parts of the volcano. And that's why I thought we'd cut through some of this other data like this. Right? So once again, the 3 pulses there. And looking in cross-section, there's our East Rift population and the Southwest Rift population, and a gap right in between them there. So this is the area that we're still wondering, is there magma moving between the two through a crack that's open enough that it doesn't cause earthquakes? Or is there some coherent block where the southwest one is pushing a block, and then because the block is coherent, the other end of the block is also quaking over on an East Rift connector? That's still not exactly clear, but we'll wait and see as the story evolves over the next few months here. One last cut through. Let's look at the East Rift connector down to the south flank. A is to the northwest, and B is to the southeast. And here you see also not quite as clean. We do see the pulses, but never quite stops. And that's likely because the south flank is almost constantly active, and that gives it this constant incline rate that is the background beyond the pulses here. This is what it looks like, depth versus time. There's no real pattern there. Unlike the other pattern, we don't see these vertical strips, right? It's much more distributed around here. And this is going to show it's not exactly the same thing happening in that upper East Rift connector and the south flank, both of them. In either area, we don't see that sign of magma pushing its way in and flaring a whole range of depths in a short time. Right? So that's interesting to note. And one last thing, one last cross-section. Remember, this is the southeast to the right at B, and northwest is A. So here is our upper East Rift area, and these darker red colors are the ones above sea level. So it is getting pretty shallow there in some areas, forcing adjustments. But this is the big south flank earthquake we saw on Monday, the 5.1. So a huge gap there, right? So this is the whole Koaʻe fault zone all through here. And you could imagine that maybe the pressure building to the northwest is what's pushing against the south flank. And that could be what flares off this 5.1, right? So here is this bridge between the volcanic earthquakes and a tectonic earthquake through the transfer of stress and pressure across the volcano here. So that's enough cross sections there, but that's when I show you, here is this map of the week once again. And I wanted to point out this cluster. Let's get my red color back. This cluster here in the East Rift connector. Let me zoom it in so you can see a little better. I'll come back out again, but notice how diffuse it is. It's pretty roundish, right? Like a cloud. And showing that it is adjusting in that area, but it's pretty widespread adjustment. Right? It is similar to what you see in the Southwest as well, which is interesting too. Maybe suggesting that this is not purely volcanic injection, but also moving faults. But the reason I wanted to show this is I want to flip back from this map, which is from this week, to the last week we had activity on an Upper East Rift connector back in 2021, July 13th. And look at how linear, when magma was in that Upper East Rift zone, that earthquake pattern actually looks. I'll zoom it in so you can tell. There it is. This diffuse area is the crater itself. So we're looking at right here as what that earthquake pattern looked like most recently. It looks pretty different than what we see this week. So I'm still pretty suspicious about this Upper East Rift connector area, whether there really is magma in there, how far it's gotten. Certainly it's moving a lot as a result of magma filling this whole area, at least over here. But how close is it is the question I'm asking now, to have some idea about what might happen next in the volcano. Because if I come back to this map from last week, right there, from this past week right now, this big earthquake on a south flank, it is moving an adjustment to this triangle, the Koaʻe. But once this south flank starts to move and the section next to it starts to move, that is what you need to start to open the Middle East Rift Zone. We're looking, it doesn't seem to have happened yet, right? It's not something that might be instantaneous, but this is one of the first clear signs that that is preparing to happen at some point in the future here. And the flank is starting to move because we've seen pressure affecting this area, and now it's able to push hard enough to start moving this south flank. So that says two things. One, a lot of magma filling up a lot of space in here, right? That it can push. And two, it's able to push, and a south flank is moving as a result of that pressure. And so that's the earthquake map. To come to our tectonic earthquake segment here, this is actually a cross-section made for the 2018 Kalapana earthquake, the 6.9, but it's really the exact same situation. Rather than being on a lower East Rift, Middle East Rift zone, think of this as the summit, and these would be the cracks in the Koaʻe that are getting filled with magma, which is now beginning to exert pressure. That pressure pushes the south flank. That gives you your earthquakes and slip and aftershocks and all of that. So one thing I wanted to speak to, and this is something that was a little hard to find, this is a lecture from UCSD, San Diego. And what I'm trying to get at here, I'm going to just talk through all I want to care about on this graph. There's a lot on here that I don't care about. But we're looking at magnitude versus the length of the fault that breaks on the surface, right? And there's a pretty linear relationship on a logarithmic scale here. And so you actually can deduce an equation that combines or that relates the magnitude to that surface rupture length. You can also relate surface rupture length to the displacement. How much did that fault move, right? In the case of us with the south flank, because of the south flank is moving away from the rift zone, this equates to how much did that crack possibly open the rift zone? And if we're curious, what are the effects of an earthquake like this in the rift zone? What are we really talking about? So you can also make an equation for that. Now, it's important to note that these values have quite a lot of spread, so there is a lot of error in here. It's just a range that you get, but you get a ballpark, right? And the answer is, for a 5.1 earthquake, is 4 centimeters. And so you're looking at a couple inches of opening, but that could be along a half-mile length or more, right? So not a whole lot of opening, but over a wide area. That could be the start of a process where it slumps more and opens more and slumps more, and that may eventually have consequences on a rift zone there. So that's one example there. I thought I'd show you another example here from another research paper, just once again emphasizing the range of values, right, that you can get. So here you are. This is more or less 2 centimeters up to 10 centimeters for this magnitude range of 5 from other areas of the world there, for example. Okay, so bringing it together here to our volcanic earthquakes and south flank. This whole area is moving as a south flank. Here's our cracks that can be injected. But one curiosity, which has been hanging over us for the last couple months, is the satellite measurement of uplift is actually northwest of these earthquakes. It's this big fat zone in here, filling with magma. This is an area that activated back in 2005 and was described as a mush zone and fairly flat and horizontal. And if that's the case, that's about the same shape as these faults that we have. If I come back to, let me find the right one here, our original tectonic earthquakes cross section here. What could happen is if you're pushing over this way or pushing over this way, there could be areas where you have interaction of the magma and the faults, right? Because the faults are moving, they're weak zones in the volcano, and if for some reason they allow the magma to infiltrate, then you can have a magma potentially adding some, it's hard to call it lubrication, but some form of easing the friction of that fault and allowing it to move further. So you have some combination of faults and magma together that can occur here, especially near the summit, especially when you have this south flank structure with shallow faults. Here's one drawn, but there are others like that as well, right? And there's even some that go like this too, the other direction too. So a lot of complexity happening in there. Where am I here? Yep. So that may be why we also have this diffuse area, and why earthquakes are only happening on one side of that area, as that area is trying to push, and this is where it's catching, right? So it is magma filling in, but more so the fault being pushed by this injection of magma. One way to think about this is if it was magma pushing through rocks and breaking rocks, how often can you break that same rock in the same place over and over and over again? It's been 2 months of this. So it's less likely that that there's some piece of intact rock, the magma is just finding ways to break it over and over. And it seems to me more likely that you have some fault zone in there that's grinding those rocks as a result of the magma pressure. And the magma maybe is helping inject in there to keep that thing moving, right? And even if it's just cooling and forming glassy rock, and that rock is getting ground into a powder or a dust more easily than other rock that was not quite so brittle, that could be enough to help it move, but even without it being liquid per se, right? But this does remind me of that famous example in geology of why do faults move? And there were 2 geologists at the bar, and one took his pint of beer and slid it over to the other one across the bar and realized that the glass was able to move pretty easily. And that was because of the water underneath that pint glass that created a little layer that then reduced the friction and allowed that fault to move. So water pressure, any fluid pressure within faults is hugely important to allowing them to move more easily, right? And that's why in areas like Colorado in the 70s, when the Air Force was pumping nuclear waste deep underground into fault lines, they increased the rate of earthquakes by over 100-fold in that area. I think it was over 100-fold in that time. So, and then when they stopped injecting the fluids, the earthquakes also stopped. Right? So clear examples of how pumping fluids and pressure down at depth does facilitate earthquakes to move, or faults to move and cause earthquakes. So it's a lot of earthquakes we're talking about today. I'll try to wrap it up here with one last segment on our flex earthquakes. And here is a model from a paper by Fred Klein, a former USGS seismologist, HVO. And the basic thing here to take away is that under the island, there is essentially a hole. The crust, the ocean crust, is getting pierced by the magma pathway through it. And this crust is actually sagging downwards, it's concave down underneath the island, which is opposite of what we used to think decades ago. We thought the magma would come up, it should push the plate up, everything should be deflected upwards. But now we're seeing actually a punctured up, and we're seeing a sagging of the edges down here, right? So what that means is that in the shallow parts of the island, the direction with the most pressure is actually away from the center of the island, right? Think of it as gravity. The highest point is in the middle, more or less on average, and you want to have motion away from the center, right? But at a certain point, when you get a certain depth beyond what they call the neutral plane, which here is at 20 to 22 kilometers down, that's right around 13, 14 miles. Right around in there, you get deep enough that you're not really moving sideways with them with pressure anymore. Now, the pressure is stronger going towards the center at depth, right? So that's a difference of direction there. And a neutral plane is where it is none and switches from one to the other there, right? So that's an interesting division within the Earth, and they actually can map earthquakes, all the earthquakes, and depending which depth they fall in, they see this alignment of which direction the energy is moving based on this, what they call a stress pattern surrounding these locations. And it turns out that deep under Kilauea, at the roots of Kilauea, this area actually intersects this zone of bending of the plate. And in fact, it's near the area where it bends the most. So there's a little interplay happening there between Kilauea's magma source, its conduits and supply lines, and this zone of deep pressure. And for this reason, Kilauea has had deep earthquakes flare off for a long time in this area. We maybe don't feel them as much recently as they occurred in the past, but they have been happening for a while. So just to share, nope, that didn't work out for me. Let's see if I can reload. No, it doesn't want to do it. Okay, let's do this. I'll pull this screen here in front. Oh no, there it goes. All right. So first I'll zoom into this image, then I'll show you the title of this paper here. But these are earthquakes under Hawaii, deeper than 20 kilometers, from 1979 to 2007. And what you can see there is that hole, the stress center in the middle, in this area lacking earthquakes right in the bullseye, with earthquakes surrounding on all sides, especially so on the Kilauea side, where you have this zone of maximum bending intersecting this magma pathway. So we have this really unique situation here in Kilauea, and this is just a little nuance of our volcano. So let me pull this to the top and show you the title of this: Fred Klein, Lithospheric Flexure Under the Hawaiian Volcanic Load, Internal Stresses and a Broken Plate Revealed by Earthquakes. That's the title. And this was published in 2016. Okay, so let me move on to show a few last things on these earthquakes. And oh, this one is also gonna not want to load. So let's try it again here. So paper is published by the American Geophysical Union. There it is. Coming up. And this is the systematic relocation of earthquakes. I'm looking at the earthquakes that have been precisely relocated under Kilauea here. And there they are, showing the zones that we've been talking about today, with the rift zones up there. But also we're cutting through at depth, right? So this panel cut through, this is 2 different panels, 0 to 5, and then 0 to 20 right here. Right? So, and what they've done here is colored by year. So most of these blues are in the 90s, is what you need to know right there, right? Greens in the early 2000s, and reds more recently here, 2018. But there, deep under Kilauea, is this big cluster of earthquakes, right there, happening largely in the 90s. Some patches happening more recently, all through there, but you can see how much more present these were back in the 90s here. And then from the other direction, if you cut it the other way, you also see a huge amount of these settling earthquakes down deep into the volcano there. So different ways of looking through. You can slice through the caldera and look at the different layers, and all the volcanic stuff is in this upper level right here, 0 to 5. 5 to 15, this is the south flank area. There's all the south flank moving, all the patches of it. 15 to 20, now you have just a magma conduit. 20 to 60, now you get that extra flexure stuff all around, or more widespread. Plus you have Pahala coming in here from the southwest too. And one last one here, which is from that paper as well. Different view from the northwest to the southeast, cutting across 22 to 55 kilometers depth, just the deep stuff. Right, and there you see the deep earthquakes under Kilauea one more time, just below the neutral plane, right, depth of 21 kilometers or so, right? Now, just to come back and look at this information statement, the depth of the 4.4 was 23 kilometers. 23 kilometers falls right in there, right in the middle of all the other ones where it belongs. So there's a long pattern of these occurring as well. So we've covered all kinds of earthquakes in great detail here, maybe too much for some of you guys, but there it is. All the questions hopefully answered. Volcanic earthquakes, the flexure earthquakes, and the tectonic earthquakes south flank. And with that said, we'll now go our monitoring signals on Kilauea here, and we'll run through this more quickly than usual. And let's see if I can zoom this a bit here. All right. So I will highlight only 2 days of daily updates. First on Saturday, December 2nd, when seismicity increased dramatically in the South Caldera region before midnight and returned to lower levels just after 5 a.m. So that was one of those pulses. The key thing they keep repeating is unrest may continue to wax and wane with changes to the input of magma into the area. So that's still the same. In their observations, they note minor earthquakes also occurred in the Upper East Rift Zone during this period. Activity has subsided, but here we go. Bursts of long period activity that cannot be located accurately continue beneath Halemaʻumaʻu. Right? So they're saying that there's still long period earthquakes and tremor, movement of magma giveaways underground there. So we know magma is still moving in the area. So that's the highlight of that day. And most of the other days in between are pretty quiet. But today, once again, activity resumed at higher levels. So today's update doesn't quite reflect that because the update comes out fairly early. But they say moderate seismicity began the previous night, last night, continued low level activity in the Upper East Rift Zone, and in the southwest rift zone. So they note the 4.4 again. They note that the last swarm was December 2nd before the one today, December 7th. That's all I'll highlight here. Everything else is pretty standard to what we've seen recently. So move on to the monitoring signals. Earthquake counts today are approaching the swarm on Saturday. Looking at our depth versus time plot for the last week, you see our big shallow 5.1 on the south flank, our deep 4.4, 2 days in between, and the volcanic earthquakes like that as these bands and pulses that come in here and there. Looking at tilt for the week, you can see the volcano was going through a deflation-inflation cycle when the first earthquake hit. In case you are curious, you can note that the inflation began hours prior to the South Flank earthquake, which caused a big jolt and a small offset before inflation resumed its previous pattern. And the second earthquake also caused a small offset, smaller than the first, and otherwise hard to tell any effect there as well. I thought I would add in this week our 1 week GPS stations. There are 2 currently online. The one in the South Caldera is only giving us the up component, and the one at Byron's Ledge is only giving us the east component. Very similar patterns. It was higher earlier in the week, dropping down if I were to more or less draw a line. And you can see that mirrors our tilt signal with a little bit of a lag there. You imagine that the tilt begins coming upwards. The GPS is gonna take a little more time to follow behind. So that all looks as expected, but something we can look at in case we're wondering if the ground might start popping up higher. And what you really can see is it's not actually in the South Caldera. These are both Halemaʻumaʻu indicators. The ground is not moving up very fast or being pushed east very fast either. Okay, the map we saw. For the last month, here are earthquake counts per day. Here we are at about 200 earthquakes today across all of Kilauea. Earlier in a week on Saturday, it was similar, over 200. The previous time like that was just after Thanksgiving, Friday and Saturday, around those values as well. And before that, it was a couple of days before Thanksgiving there. We can't see the ones in October on our monthly count. We'll have to go to the year count for that. But here you see this pattern of cycles once again coming through. There's a 1 month depth and time. I'll just move past that one today. Our 1 month tilt, still showing inflation here at Halemaʻumaʻu. Right, this blue line being equivalent to this one at the Sandhill station, but compressed, as we said in our summary up top. Further down the rift zone, here is Puʻoʻo. Puʻoʻo had an offset from that earthquake as well, the big one, the south flank one, affecting both components. The smaller earthquake didn't shake it nearly as much. And remind you guys, this was that rainstorm that came through prior to the earthquakes. I did see a comment earlier about rainfall and earthquakes. I did mention how fluid pressure can affect earthquakes. That's about the extent of it there. So it can be that groundwater can percolate down into fault zones and ease earthquakes. That has been shown to happen other places. It's not as clear on Kilauea how long the water takes to get down there and what effect it exactly has. So it could be coincidence. But if you had a long enough rainy period for, let's say, a whole rainy wet season, it would be more believable to think that at the end of the season you might have more earthquakes, as all that water over months has a chance to percolate down to the depths we're talking about, right? Miles down into the earth, right? And then you have to consider, is the earth not too hot where you can have liquid water still, right? And there's a sweet spot in there for that to happen. Further down the rift zone at the Jonica station, we had a much larger jolt right there. But otherwise, no change on a volcanic system either. But maybe showing the ground was more solid and shook harder there, perhaps. At least the tilt meter did than other stations, and showed this bigger spike for that reason there. And so those of you who were down in the Lower East Rift Zone and felt that earthquake very strongly, you can know you're not alone. The instruments felt it strongest there as well. Okay, SO2 from the summit is still low. Here's a newest measurement at about 65 to 70 tons per day within that background range, as we mentioned in our VOG forecast earlier. And to kind of take in the full last month altogether, how many earthquakes there have been, the full pattern of changing the volcano all at once. Magma source at Pahala coming in from depth, feeding up through the center, driving shallow volcanic earthquakes, which push the south flank, causing south flank earthquakes as well, right? The whole sequence all together there, right? And because of all this moving parts on the surface, deep underground, within the base of the ocean crust, you get some of these adjustments settling as well. All right, so last year, earthquake counts. This is earthquakes per week now. So here we are. It's been over 2 months of this activity, which is longer than anything in the last year. Different pattern as we've been repeating for the last couple months here. This Koaʻe zone is a little different than what we're used to seeing as far as this earthquake ramping up to an eruption predictably. And here's our GPS. GPS at the summit, showing occasionally inflating, occasionally deflating. Overall, much more subdued in its expansion rate than prior to the last eruption in September there. Right? Pu'o at the Middle East Rift Zone is still contracting with no changes there. So I actually forgot last week to show you the full MOUNTS system. MOUNTS is monitoring unrest at volcanoes through satellites, something like that. I mean, I'm not quite got it right there. But this is a system designed to watch volcanoes from space. So it's designed for volcanoes that are not near population centers, that people are not watching all the time, which is not us, but because there is sometimes some lag in processing data and release from the official agencies, this automated tool is really useful to us. So let me give you an example for Kilauea, what this actually looks like. Here, if you load the volcano page for Kilauea, it looks like this. It's showing from the satellite captures how much gas comes out. It's showing when does it look extra hot, thermal anomalies. These bottom three are the INSAR images, right? With really this middle one being the most important. And how much deformation is there? So hard to see at your scale. Right there is a bump, and right there is a bump. That's June and September, 2 eruptions we most recently had. So those picked up from space. If no one had been here on the ground, it was in the national park, if it was remote, this is why this data is useful. You would have said the ground changed here and it changed here. It got much hotter at these times and these times at the same time as the ground changed. And we saw big puffs of gas flying through the atmosphere from space. Right? This is why this is so useful. But because it's automating this satellite aperture radar interferometry, we do have INSAR images right here. So you can actually go to your grid and you can look at different time windows of INSAR for, this is the 12 days for the last 2 weeks of November, first 2 weeks of November, and going back through time like that. Right. So to step you through it a little bit larger here, this was the September eruption. So a lot of incoherence right through here because the ground is moving and lots of gas and lava flows and all that stuff blocking the image right here. But you can see the center of activity is right here in the middle. Right? This is kind of looking for the bullseye. There is your concentric rings like that. Then advancing to the first 2 weeks of October, where we saw the beginning of the intrusion, clear bullseye pattern, southwest outside the caldera, right there. Then the first 2 weeks of November, you see similar center of the bullseye, but not quite as strong, right? Still centered to the south. And the most recent image we got from the last 2 weeks of November, showing the bullseye once again back in the center of the crater. So this is really showing once again how this pulsing is moving through. Depending on when a satellite captures it, the pulse is at the summit, or it's moved to the southwest, or it's coming up the summit, or it's moved to the southwest. And that's the pattern we're seeing there. And I wanted to go through that one more time just so we can look at the GPS here and understand how that all fits together. So GPS at the summit, this is 2-year GPS, 3-component, east, north, and up. And the summit is not rising very fast in the northern segments, but it is rising much faster in the southern segments still. That's the key takeaway from the summit area. On the south flank, just south of the summit, we're still rising quite fast and being pushed to the southeast quite fast. At Ahua, at Puhimau, and all the way to Devil's Throat. Devil's Throat being a little further away, now showing a more coherent signal recently here, rising as well. So that's Devil's Throat is this area right on that upper East Rift connector, right? That's near, a little bit further south of where all those earthquakes are happening. But it's also rising and being pushed mostly to the east, but also to the south. Elsewhere, the stations of note are Hilina Pali, where we're still moving south quite fast, and east quite fast, southeast pretty fast there. Not rising quite as much, although we are rising a little bit. This is mostly the flank moving away. And further towards the ocean, further from that intrusion, no uplift as well, but also showing clear south and southeast movement at Elemakule, right? So this is the area that's getting pushed by this furthest cluster of earthquakes to the southwest. So that is it. I was looking for, and it's hard to see because these are 2-year plots, I'm looking for effects of that earthquake. Did we see the south flank take a jolt to the south? And thus far, it's not really quite clear. It's just hidden in the middle of the noise of some of these stations. So we'll revisit this if we find it in the future. We do have right near that 5.1 epicenter, this station called PG2R, which is now finally back online after 2 years. And it is also showing east and south movement, with up being hard to read right there. And so more data coming in there. But as far as what the rift looks like, the rift going down, down, down. Everything is dropping down along the East Rift everywhere there. And to emphasize why this is really important, I thought I'd bring up our 10-year GPS plots, and especially back to our Kalapana Trail area. This is the area just south and west of Pu'o'o on that south flank area. The south flank, for most of the last 10 years, was moving south at Kalapana Trail. This was a 2018 earthquake and eruption, and after that occurred, Kalapana Trail was still moving to the south. And when did that change? Mid-2021 is when it changed, where Kalapana Trail began moving to the north. This is towards the rift zone. That's pushing the rift zone closed. And this is the most important key right here is, do we see this thing turn around at some point and come back down? If so, we can say, all right, that earthquake was significant, starting to change the rift zone. If we don't see that happen, then it was a smaller adjustment than that and didn't have that big an effect. And we'll have more of those earthquakes to continue doing the work needed to spread the volcano out so everything fits. Okay, so that's the GPS, as far as I'll take the GPS today. And we'll now go to Mauna Loa monitoring quickly. Mauna Loa has a report issued today for the month as well. And the bottom line is most of the earthquakes have slowed down. The deep ones especially, the shallow ones somewhat too, but the shallow ones are still ongoing. Nothing else to really report there. And I can show you that to you. First, looking at the signals on tilt, that big earthquake also shook Mauna Loa. We know it was felt all the way to Maui, so big jolt there, which I actually like because this blue and green line scale, the way it's scaled here, is actually more of how we should be looking at Mauna Loa. These small variations that we see day to day, they're small. They should be just that subtle. We're more looking for these longer term ups or downs or that kind of thing, which there is none of right now. So this is really showing how quiet Mauna Loa actually is by filtering out some of that daily variation a little bit for us. Depth versus time. The deep zone would be right in here. There's one tiny dot. So that's the only one in the whole last week here. And shallow ones, not a whole lot either. There's 12 of them in the shallow region. So for the month, tilt pretty flat. Earthquakes, depth versus time, but almost a whole month with very few deep earthquakes. Shallow ones are still there, but once again, very low background levels. And so we showed out a maximum rate of 5 earthquakes for the last month here. For the last year, there is that adjustment we saw last month, and since then, quieting down. This perhaps related to the movement of Kilauea's southwest rift, its south flank, which leans on Mauna Loa as well. And as we mentioned over an hour ago now, that little bump fits in right over here, and it's really piddly compared to the buildup of eruption in Mauna Loa last year and the years prior. So earthquakes this past week, this past month, and this past week here. Not a whole lot of ink on these maps. And that's it. Pretty quiet on Mauna Loa, and that wraps up Mauna Loa for today. So we'll wrap up here with a couple of final things. Volcano Watch. Today I'm going to do something a little different just because it fits in. I'm going to pull a Volcano Watch out of the archive from February this year, entitled The Missing Slow Slip Events on Kilauea's South Flank. You can see how this might be relevant now. But they were pointing out how before 2018, the South Flank had these occasional bursts of what they called slow slip events, sometimes referred to as slow earthquakes, where rather than the fault moving all at once within a few seconds, it's doing so over a few hours. So you don't feel the jolts, you don't feel the shaking, but geologically it happens also within a day and leaves a clear signal on your instruments. So this was happening in a fairly regular period before 2018. But after 2018, those events stopped. Why? It all comes back to the 6.9 earthquake in 2018. It's believed that that earthquake moved so much to the south flank that it may have changed the dynamics, the equilibrium, really, right? Because the dynamics are going to return to what they were, but for now, it's still recovering from that movement induced from 2018. So just to emphasize how much the whole south flank is still feeling the effects of 2018 and how things really are different and rebuilding ever since then. That was Volcano Watch from February. Today's Volcano Watch is promoting Volcano Awareness Month, which is next month, January 2024. So this article is posted for you to check out, but I'll we'll move to this other version of it, where it actually outlines all different talks. Okay, so here is the calendar. You see the first week of January is empty, thankfully there. And then it picks up with a fury. There are 5 hikes. Kahuku on the 7th, Kilauea Iki on the 13th, Mauna Ulu Fissure on the 20th, Sulphur Banks, Kulamanu on the 27th, and back in Kahuku on the 28th, Pu'u Lukuana, right there. There are 4 after darks in the park on Tuesdays. The 9th will be Kilauea's crater-filling summit eruptions. That'll be Matt Patrick discussing the 4 eruptions in Kilauea since 2018 at the summit. The week after that, eruptions near Kilauea summit. This is Koaʻe Fault Zone, right, by Steve Lundblad from Hilo Geology Department. The next week would be Drew Downs on Kilauea's southwest rift zone and a Great Crack. Historical eruptions out there. Probably some overlap on some of what we've talked about over the months here. And finally, the last Tuesday of January, Mauna Loa 2022 eruption and recent observations by Frank Truesdell, right there. Those are the after darks in the park. There are additional talks occurring as well. There's a few of those. What's going on with my screen here?
Looks like you've frozen your camera. Yeah, we can hear you. Your camera's frozen. I believe your screen share is also.
Okay. So you're going to say some thank yous. I just wait till this clears up and I go through it.
Yeah, we might as well
after
go
that.
ahead and knock some things out. So we appreciate everybody being here today. We rely on viewers like you to help share this type of screen. There is no advertising budget or anything like that. So we rely on word of mouth and people helping us with the algorithm. So if you haven't liked or subscribed yet, consider doing so. It's free. We do take donations as well. We have a few here I'd like to highlight, but we also take donations on hvari.org/donate. If you would be so kind, those are tax deductible donations as we are a 501c3 nonprofit. All right. So we did have some donations. Tim Hazeltine came through with a $50 super chat. Says mahalo for your weekly presentations. Appreciate that there. That 50, Tim. And we lost Phil. Phil is gone. Welcome to the show, Lou. I know it's been a long time since we've done this, but
well, good evening.
Yeah. Appreciate it. Just hop in here while we're just doing some donations. Scudget Ed came through with 2 donations. First one was a $20 super chat. Says, again, thanks for all your hard work, Phil and Dane. I appreciate that. And then a 20 as well for a sincere mahalo for Dano and Carrie. Appreciate the American Sign Language there, guys. He was also wondering about trying to get into ASL as well, but yeah, that's a conversation maybe we can follow up on. So yeah, Phil is gone. You are stuck with me now, and we are trying to just go through some of these donations. We did have some questions as well. Any of these that I feel like trying to do? Was that Tectonic? I mean, we're talking. I think Phil went through that pretty well. The Tectonic stuff. Let me get that super chat out of there. Let's go ahead and get that. Oh, let's see what we got going on.
Hey, why don't you go with this one? Because you can answer this one from Victoria. She's asking Phil, but you fill in on this spot, no problem. She says, I really would like to hear about your firsthand experience from that 4.4. Maybe not just the 4.4, but any of your experiences with an eruption at the house. Or not eruption, earthquake.
Yeah, I'll go ahead and do that one. Might as well. So for me, these 2 earthquakes, the first one was more significant, the 5.1, than the 4.4. The 4.4, it came in 2 parts. The first part was not that strong. The second part was much stronger. The first part I blame the dog for. Hey, there's Phil. We'll add you back to the stage, Phil, after this little. We're doing just one question real quick. So that one wasn't that big for me. Phil's would have been more intense. The 5.1 though, that was a rather decent jolt. Nothing fell off the counters or anything like that. I don't know how people like, unless the earthquake goes on for a considerable amount of time. Like I just do not have, like it starts shaking. I'm like, oh, is the lights going to go out? Is the power going to flicker? Stuff like that. I'm just, seeing, essentially just how it's going to feel for us, right? And like how intense is this going to be? Is this something? And then by the time it's over, I'm like, oh, okay, maybe I should get up and do something, right? Because it's
we don't really have much time to just
right.
waiting to see what the house is going to do for that 3 to 8 seconds.
Right. And we've been through, like, I've been through so many that I don't like when I feel the earthquake, I don't like, immediately jump under the desk. I'm like, all right, so how bad is this going to be? Just sit there and be like, all right, it's shaking, but really, it gets much larger than these ones that we've had. These 5.1s and stuff like that, they're not the real ones. It's that like when they get over 6 or 7 or even 8, then they're big deals, right? All right, so if we have Phil back, thank you for jumping on here, Lou,
Anytime.
to going through a little bit with us. All right. Oh, there we go. Now we got it back flipped together.
All right. Thanks for bearing with me, you guys.
Yep.
I'm still trying to figure out what's going on with that. I restarted everything today, and sometimes it just still does it. All right, so let me wrap up Volcano Awareness Month. We've been going on for a while here. I mentioned the After Darks in the park. There are a couple of talk story sessions. One at Na'alehu on the 10th at the library. Kevin Kobayashi will be there, HVO technician. And another one on the 15th, which is a holiday in Kona, Hawaii Keiki Museum, will be Katie Mulliken over there. Beyond that, there are a few other talks outside of the national park. The first one is at University of Hawaii Hilo on the 17th on collaborative geochemical monitoring. I believe that is Kendra Lynn giving that talk. There is a talk in Pahala at the community center on Thursday the 18th, 6 p.m. on earthquakes deep beneath Pahala. This will likely be a live stream in lieu of our regular update, since if you look, it'll be something happening every day this week. We probably won't have time to do our own, but we'll stream as many of these as we can. On the 19th, Pahualapa Museum, 3 p.m. That will be Mike Zoller on the 19th, talking about mapping during the eruption there. Right. We'll keep going here. Kailua Public Library, earthquake monitoring on the 25th, following Thursday. There is a coffee talk at Kahuku on an 1868 Mauna Loa eruption as well. And let's see here. One last one on the 31st at University of Hawaii Hilo, volcanoes in American Samoa. Right, so quite a lot of talks there. On this page, details, there are maps, descriptions of the hikes, like how far each one actually is. It discusses whether the hike is being led by a national park ranger or by the geologists. So I thought I could highlight in particular the hikes led by geologists. This one, actually, Kilauea is Park Ranger Miket Gallegos. The hike on, let's see here. Here it is. The Mauna Ulu eruption, 69 to 74, is being led by UH Hilo professor Dr. Liz Gallant, who was on HVO staff as well. Okay, so led by a geologist. There is a hike in the 1868 talk. Oh no, this is a talk, not a hike, by Katie. This hike, the Sulphur Banks hike, which is offered daily by the national park, on this date will be led by the gas specialists, Tricia Nadeau and Christine Sealing. And those are the geologist-led hikes, I believe, there as well. So that wraps up the program for, oh, we're still on the screen here, for the Volcano Watch. I'll just throw the calendar back on the screen here, and we'll remind you, because this will mean a lot of schedule changes, a lot of content in a busy month of January. So as we approach the end of December, we will update you guys on the schedule once we figure it out ourselves. All right, so that is the Volcano Watch. On our community side, there's not a whole lot to share, but as usual, if you're coming to the national park during this holiday season to check out all the changes in the landscape that have occurred over the last year here, then make sure to check the alerts and conditions, because there are closures for Nene, closures for earthquakes in the desert, closures for a recent eruption in Mauna Loa, and right now that's it, but that could change. Right? There are programs in the park happening in December, but none of them are geology programs. In fact, there are really 2 holiday concerts remaining, one next week Tuesday, the Carolers Quartet, and the following Wednesday on the 20th with Lido Archangel. And so that's December, and then January, it's mostly Volcano Awareness Month once again, but without inclusion of all the stuff happening outside of National Park. So that is Community Corner. As Dane mentioned earlier, this is our donation page at hferry.org/donate. Whoever he said thank you to and I wasn't on to hear, thank you from me as well. And Dane, I'll pass it back to you here.
Yeah, so we got through that part. Had a few donations. Thank them. Did mention the hferry.org/donate if you want to make a donation and the tax deductibility of those. We did have a couple questions, but we are going late, so I'm only going to throw you 2. I tried to do as many as I could as well. So let's see here. What's the good one? Okay, so Victoria asked what areas comprise the upper rift zone. We're talking about the upper east rift zone and the middle east rift zone. And
the upper east rift zone is the area from the summit to the bend, which is at Mauna Ubu. Yeah.
And would Iki be considered, Kilauea Iki be considered upper east rift zone, or would it be considered summit, or would it be like a gray area between the two?
It's technically within the caldera collapse faults, so it's within the summit, but it certainly is a possible pathway and connection zone into that upper east rift connector. So it is a little bit of both, but it is squarely in a summit.
Right. Scott Ed asked, Phil, what was, you're wondering, you got 12 inches of rain. That's 62 cubic pounds, or pounds per cubic foot of weight. Does that have any effect on the swelling or other changes?
Yeah, I think the easiest way to answer that, Ed, is that we do see signals on tilt meters when it rains. Right, so we're clearly seeing the weight of the water affecting the tilt of the ground. And it also tells you how long it lasts. It doesn't last that long. So it kind of moves through like a front, like a wave, and then it dissipates after that. So it can have an effect. You see it on the tilt meter, and it could be, if your volcano is set up just right. Oh, my windows are rattling as the earthquakes are happening again right now.
Must be under you, because I do not feel it.
Yeah, I'm pretty close up here. We've been rattling for a while here. So, what was I saying here? The pressure comes and goes pretty quick. If your volcano is just ready to go, then that could be the straw that breaks the camel's back, or that could be what sets it off. But most of the work has been done already, right? Like someone's pushed the boulder all the way to the top of the hill and left it propped up and someone else came and gave it a little nudge, and like that little nudge could be the rain. But all the work itself is a volcano getting a boulder on the top of the hill, getting everything ready to actually erupt. And in that sense, the water is not enough force to make it erupt by itself if it wasn't already going to do it regardless.
Yeah,
so it has an effect.
right.
And more so if you have more than one day, but weeks and weeks, months and months, then it can have a more potential effect as well.
Right. All right. Sorry we didn't get through more questions. We're coming on an hour and 40 minutes here pretty quickly. We will try and get to as many as we can in chat as well. So yeah, unless something happens, right? That's only the thing is we do Thursdays at 5 p.m. It's our standard update. Unless something happens, we didn't really consider those earthquakes, big enough to go live on, but if something like a little bit bigger type of thing or an eruption or something along those, we'll probably go live or put an update. We did put updates on Hawaii Tracker on the Facebook group in text form. So if you were part of the Facebook group, you got notified, and we went through and updated the information as it got filtered in, as the automated, and then the review process by the seismologists and the automated systems that support them. We're able to detect the earthquakes and give us some information into where we are now with our semi-final. Like, they can be adjusted still, but they're pretty close at this point, right, on the refinement process on those quakes. So yeah, we will be back if something happens. Otherwise, we'll be back in a week.
Yeah, thank you guys. I see we got to 100 likes on here, so we have more viewers than that. Thank you all.
We do have an update on the we did run the poll again, and still 2/3 of people think it'll be before December 31st on the over under on Kilauea eruption before the end of the year. So that would make 4 eruptions. Our fourth quarter eruption, they still think it's going to happen.
It well could.
We will see.
Yeah, well, I probably fall on the other side of the line myself still.
Me too.
But we'll see. I'm a natural skeptic, right? Like, I probably won't believe it until I see lava out of the ground every single time. So take me with a grain of salt from that point of view.
Right. But it's interesting that that poll hasn't really changed all that much. I think the first time we ran it, it was maybe at 75%. And now it's down to 66. But we've done these polls before, and we've started off and everybody's on the under, then it starts eking up towards that time, the ending date, and people want to change their votes. Right. Right now people are sticking to their guns, right? They're like, oh, it'll be under. So that's interesting. We'll see. It's just a fun little thing.
Yeah, we'll see. If she does it, we'll be here. Whatever day of the week it is, we'll pop in. But otherwise, we hope to enjoy our holidays as well. We done a whole bunch of work this year. We're still moving at light speed, it seems like. So we'll see what happens with the volcano, if she gives us a little more time or not.
Want to do some final thank yous. Thank Dano and Carrie for providing the American Sign Language. They will be gone for the next 2 weeks for Christmas, a little vacation, a little bit of work, and then they'll be back. We also want to thank Two Pineapples, Lou, for jumping in and helping us with that brief little time. That we had Phil step out, but really, Lou has Two Pineapples. They have the monitoring 22.6, so it goes down sometimes. You got to deal with it, but it gets up most of the time, right? And it provides the seismic activity, the current video streams, and all the different stuff that you might be interested in at any given time, and also the chat and stuff like that. So definitely check out them.
Right on, Dane. Thanks for that. Thanks for leading the chat and holding everything down. Thanks once again to Lou and to Dano and Carrie from myself as well. Until next week, unless she forces us to come on sooner, from H. Very, he's Dane DuPont. I'm Philip Ong. Aloha, everybody.